This is it, biochar. So I want to welcome everyone to this biochar webinar on soil health and productivity. So a number of us are with UVM Extension. I'm Suzy Hodgson with UVM Extension Center for Sustainable Ag. And you probably just heard from my colleague, Leila LaRosa, who's been fantastic at doing the outreach, helping me with the outreach for this. So first, thanks for everybody for taking the time out of your day to join us. And I also want to thank our supporters. So we have a USDA Northeast Risk Management Education, and also the Northeast Climate Hub. So I've been working closely with the hub as part of a project called CCMO, Climate Change Mitigation and Outreach Education. And last summer, we completed a needs assessment within for NRCS. And what was interesting is that soil amendments and biochar rose to the top, not the tippy top, not first, but I think it was third on the list. So one of the goals of this webinar is to see how we can develop success stories and tools to help NRCS planners, in turn, help farmers who benefit from the use of biochar. So what is biochar? That should be a straightforward question, but biochar is really a category of a wide range of products for different uses. The definition I have here is from the International Biochar Initiative. So one is solid, and I put in a parentheses, carbon-rich material, because the carbon is locked up in the biochar. So different than, say, charcoal, where you're burning off the carbon's locked in. So it's obtained from thermochemical conversion called hydrolysis, and that's important that it's produced in this limited oxygen environment. So the carbon's locked in. And as I mentioned, it's a category of products. So it can be used itself or it can be blended with other products for a range of applications, including soil improvements. And the IBI International Biochar Initiative emphasizes resource use efficiency, remediation, and protection against particular types of environmental toxins in the soil, and as an avenue for greenhouse gases. So just to show there's a wide range of uses for biochar and their particular characteristics. So we go to the next slide. Okay, some of the biochar attributes that I highlight here, I'm going to just go through them quickly because our speakers will be talking more about this, but it has high porosity, a high surface area, and consequently a high cation exchange capacity. It has a liming potential, which can be useful for your soils. There are lots of reference papers. I'm just going to touch on this, what some of the benefits of biochar are. Increasing nutrient availability at certain times, increasing water holding capacity. You'll see some of the references here. Immobilizing heavy metals, reducing heavy metal toxicity. And then I think the last one is the most important. How does it affect crop yields? There are different studies that have different results depending on how and when it's measured and how the biochar is applied. We'll hear more from our speakers on this effect on crop yields. So I just wanted to lay out some of the main attributes of biochar as an introduction. And the next slide. As I mentioned, biochar has lots of different uses, and we're still at the stage of figuring out what is the potential and full impacts of these uses. So even though biochar has been around for thousands of years, it has new applications. So you can see from this table that agriculture is the bulk of the current uses, both as an NRCS practice for soil amendment and also as a manure pit cover. But it's just to bear in mind that there are other practices, including remediation in different areas, depending on different site issues. So a biochar producer will be looking at all of those market uses. But today we're really going to be focused on biochar being used for crops and also being used to manage manure and livestock. Next slide. Okay. Yay, the video is working. So this is a perfect segue to our two speakers from Shelburne Farms. We have Molly Webb and Sam Dixon, who are going to talk about the innovative work that Shelburne Farms has been doing with biochar. They've been using it for a number of years, applying biochar to their manure pit. And I love this video because you can sort of feel for like, yeah, applying biochar does generate some dust. You get an idea of, well, not quite the texture, but what it involves in terms of the scale of application. So I'd like to introduce Sam and Molly. You're on. Take it from here.
Hi, thank you so much, Susie. I'm going to quickly introduce myself before turning over to Sam. Hi, everyone. I'm Molly Webb, and I'm an advisor on climate action at Shelburne Farms and have been part of our work driving to net zero by 2028. So we only have 2 years left. Of course, the dairy is a big part of getting to net zero for us, and our applications of biochar even predate the sort of board's strategic goal to reach net zero in 2028. So Sam will speak to that. We started because we were starting to apply biochar, we had questions. And we started to convene to talk to people, including UVM Extension and researchers and others who were producing biochar. We use standard biocarbons biochar now. And so we were talking to various people in the community and wanted to bring them together around from the Northeast to see if we could learn. And I think what we first convened about a year and a half ago, and again in June. That photo you saw of Chad and Richard inspecting biochar was from that meeting. So we've definitely been on a journey, but I think we still have lots and lots of questions. So that's why a session like this is really helpful. Because even if we don't have answers, at least we can still contribute here. So over to you, Sam. I'll post a bit more about our net zero goals in the chat.
Uh, Thanks, Molly. Yeah, my name is Sam Dixon. I'm the dairy farm manager here at Shelburne Farms. And so I'm just going to talk a little bit about how we've used biochar on the farm over the years and our different experiences with it. And then hopefully I'll throw out some questions at the end and just kind of questions that have come up over the years as we've used the biochar. We've actually been using biochar on the farm for quite a number of years. It started way back with, I believe it was Don Ross's soils class, where we put a biochar filter in one of the drainage ditches coming off of the dairy, and it actually helped clean the water, but quickly became charged and full. And then in 2019, we got a big trailer load, like you saw being dumped in the manure pit from Quebec. It was a byproduct of the charcoal manufacturing up there. And there were some problems with it using it for us. It was from so far away. We weren't comfortable with the level of deforestation involved with the production of the biochar. And then I think the next year we tried an experiment with the same biochar of actually adding it to the barn floor. We put some monitors in the barn to try to understand what was happening to the gases in the barn. Um, and Nothing conclusive came out of that. We were looking for a permeable cover to our manure pits to reduce the greenhouse gas emissions. That was part of this plan of reducing emissions from the farm, was around, you know, reducing emissions, sequestering more carbon, reducing emissions through the cows through methane. And so the biochar was really going to help us with the manure emissions. And it was a material that worked well for us because it could cover the top of the manure pits. We could use all of our existing equipment on to spread the liquid manure, and it just seemed like a really good fit. Then I think it was 2022, we started with the material from NextChar, which is from just down the road in New Hampshire. It's a byproduct from a energy generating plant. Uh, it was a good material, but it had quite a lot of ash in it, and some people would refer to it as fly ash. Had very high potassium, which was an advantage, but it wasn't like real biochar. We did that for 2 years. And then starting in 2024, we got purpose-made biochar from standard biocarbon and added it to the manure pits. A much different material, almost pure carbon. And while the stuff from NextChar did have a higher pH, the NextChar stuff was, real light, biochar. Um, And there are some other uses on the farm. We're using it in our compost, where we compost food scrap waste from the inn, and I think Josh is adding about 10% biochar to that compost mix. And he's also using it in his chicken barn to cut odor, and as part of the sort of the bedded pack for his chickens over the winter to kind of cut the ammonia in the barn. So that's been our use over the years. So we've had several years of experience, and some of the things that I've noticed is almost an immediate reduction in the odor coming off the pits. It's just dramatic. It really cuts the odor, and it even cuts it while we're agitating and spreading, so that there's much less offensive odor associated with the liquid manure. That leads me to believe that it's trapping a lot of those gases, a lot of the ammonia and a lot of the really noxious gases are getting trapped, and catching that nitrogen and hopefully putting it, getting it in a stable form and then putting it out on the fields. Interestingly, we haven't kept as good records as we should probably, but we did keep track this past year of the liquid manure samples coming off the manure pit, and then we standardized them to so they're all the same dry matter basis. And the liquid manure with the biochar added had almost twice to 2.5 times more total nitrogen in it. So that leads me to believe that we were trapping a lot of those gases and capturing that nitrogen and locking it into the biochar. And we don't have good crop records. This is an area that we really need to look at, but I do think we've been seeing higher yields from those fields where we've added liquid manure with biochar.
Yeah, thank you, Sam. I think that's a really good segue to Sarah about we've heard some of the benefits of biochar. And Sarah, do you want to turn on your camera? Because that segues well to some research on field trials that Sara Kelemen has been doing. And first, I want to say she was formerly with the USDA Northeast Climate Hub. She's now with American Farmland Trust.
Thanks, Suzy, and thanks, Sam. It's really cool to hear about the innovative stuff that Shelburne Farms is working on. I'm Sara Kelemen. I work with American Farmland Trust. I'm a soil health specialist based in Maine. And I'm going to talk about the biochar demonstration trials that we are working on right now. This project is a national project. I lead the New England trials, which are in Massachusetts and Maine. But these are all the people I work with, and they're instrumental in making this happen. Okay, I'm going to turn on my timer because I have too many slides and I already know. So I'm going to push it, so timing myself. Okay, so this is kind of the why for this project. As many of you probably know, NRCS has a practice standard for soil carbon amendments. And there are, many different options under the 336 soil carbon amendment practice. Biochar is one of them. And there are a lot of questions about how to use biochar most appropriately. And so American Farmland Trust has a conservation innovation grant from NRCS to kind of explore how are we using biochar appropriately in agricultural systems across the country, because we're getting questions from farmers like this. Is it a fertilizer? The answer is no, it's not. How does it work? Suzy kind of touched on that. Will it work for me? What is it? These are kind of like the questions that we hear over and over again. Is it a standard product? Again, the answer is no. How is it tested? How do I interpret the test? How much does it cost? How much do I apply? How do I apply it? What type do I use? How do I charge it, or make sure that it's not taking nutrients away from the plants? And will I get a return on my investment? These are kind of all of the driving questions that lead to this project happening. And therefore we have this. It's a national conservation innovation grant project. We have trials in Washington, California, Nebraska, New York, Illinois, Kentucky, Massachusetts, and Maine. And in Massachusetts and Maine, we are focusing on in Massachusetts, it's high tillage, low organic matter vegetable production farms. And in Maine, we're looking at kind of like a diversity of production systems and soil types. And I'll get to more of that a little bit later. So what are we looking at? We are looking at change in soil health over time. So we're doing both an infield soil health assessment and Cornell comprehensive assessment of soil health, both before the biochar is applied and then at the end of the trial, which is 3 years long. We're also doing standard soil testing as well. That's just not in here. We're looking at the economic outcomes. So we're collecting field operations data, both from the biochar and control plots, to compare, if the farmer had paid for the biochar, as part of the project, we're paying for the biochar. But if the farmer had paid for the biochar, what would their return on investment be? And then we also are doing social surveys. So, asking like, how is it working for you? How do you feel about this? Are other farmers thinking about this? That kind of thing, so we can gauge interest and adoption across the states that we're working in. And we started collecting data in 2025, and we're going to wrap up data collection in the fall of 2027. There are 14 trials across Maine and Massachusetts. In Maine, there was no kind of restriction on which farms we could work with. In Massachusetts NRCS wanted us to work with farms that had less than 3% organic matter in the soil, in the fields where we wanted to do the trial. We have applied biochar on 7 vegetable fields, 2 corn fields, and 4 hay fields. It's in a total of 30 acres of biochar applied to date. And we've been using biochar from standard biocarbon and clean main carbon. And this is just a cool visual, so you can see what it kind of looks like before it's tilled in. On the left is what 60 yards per acre looks like, and on the right is what 20 yards per acre looks like. Here's our experimental design, 2 examples. Most of the trials are really simple. So on the left, it's just like replicated 3 times and randomized, and there's only 2 treatments. And on the right, we've got 1, 2, 3, 4, 5 treatments replicated. So a little bit more complicated experimental design. And on there's one farm that has PFAS contamination, and that is something that we've been able to partner with the University of Maine Extension, Purdue University, and Northern Tilth to look at whether different types and different rates of biochar applied can reduce uptake of PFAS in different forage crops that are planted in this field. And there's our experimental design overlaid over this cool drone photo, so you can see what the different application rates look like before it was tilled in. And our partners have found in previous research that high carbon wood ash reduces PFAS uptake in a greenhouse study with contaminated field soil. So this is kind of like expanding on that and seeing what we can see from that. And this is the first year. And spoiler alert, we haven't gotten our PFAS results back yet, so you won't be hearing about that. What have we learned so far? So one of the big things is particle size. For agricultural use, I think there is such a thing as too big. I've come across some biochar that is not. We're getting particle sizes that are like in excess of 1.5 inches. And because such a big part of the mechanism of how biochar works is the soil contact, I kind of think that having these really big particles isn't going to allow for the biochar to do what we want it to do in an agricultural setting. However, I will say that if you use a manure spreader and you turn the beaters on, it does a pretty good job kind of pulverizing the biochar as it's applied. So it's not like technically sized biochar, but you can make the biochar smaller as you apply it. We have learned a lot about spreading safely. We applied some biochar on some days that were too windy and got like a face full of black dust. That's not very much fun. So like wearing a mask, not applying biochar when the wind's blowing more than 10 miles an hour, that kind of thing. Gotten a lot of questions about where to source biochar, and as a result, we've put together this map of biochar producers. It started out just in New England, but we've kind of expanded it, and I'll show you more what that looks like. And there's also just a lot of like questions about what biochar is and isn't, and how to use it and how much to use, that we're kind of clearing up along the way. And I think one of the big things there is just the reminder that biochar is not fertilizer. This is what the biochar suppliers map looks like. You can point your phone at the QR code and it'll take you there, or you can Google American Farmland Trust biochar suppliers map and find it. And we're looking for, you know, like if you are a biochar supplier and you want to add yourself to the map, you can do that. So here's an example of what it looks like. We have feedstock, products, if they're tested, what the distribution unit size is, that kind of thing. So it's supposed to be information for a potential customer, probably an agricultural customer. Just so you kind of can like see what we're working with here, here are 3 different biochars that we've used. Standard biocarbon on the left, a high carbon wood ash in the middle, which I think is actually the product that Sam was talking about, and then clean main carbon on the right, just so you can see kind of the difference in size. Here's the you can see it here too. Here are all the different ways we spread biochar. The only thing that didn't work was a cone spreader, and I think that was because the biochar was a little bit frozen also, so we just got these like big chunks and they couldn't get through the spreader. Okay, now we're going to talk about some results from year 1 of the trial. Let's see, how am I doing on time? All right, I got to speed up. For context, it was really dry. So that's kind of just like what you need to keep in mind as we're talking about these results. Okay, so this is the trial that had a low rate of standard biocarbon biochar, a high rate. So the low rate is 20 yards per acre, the high rate is 60 yards per acre. And then we matched the carbon in this high rate of biochar in these 2 application rates. So this is actually the same amount of carbon in these 3. And we, the only significant difference we saw was between the high carbon wood ash and the low rate of standard biocarbon biochar. Yeah, but this is what the corn looked like. So again, like, take these results with a grain of salt. It was really dry. This is a hay field. So this is first cut on the left, second cut on the right. Biochar is in pink and the control is in this teal color. And there's no significant difference between the biochar and the control for either the first cut or the second cut hay. Again, biochar on the left, control on the right. No significant difference between the biochar and the control. The application rate here, oh, sorry, I didn't mention, the application rate here is 15 yards per acre, which is, for this particular biochar, that is 1.5 tons per acre. This is 30 yards per acre. No significant difference. It looks like I forgot to put in the soil texture here. And, oh man, I forgot to put in the soil texture here as well. I'll do that. And then before Suzy sends these slides out, I'll do that. So you guys all have that when you look at these in the future. Again, biochar on the left, control on the right. No significant difference between the biochar and the control in this corn silage field. And this is what 15 yards per acre looks like on the surface before it's tilled in. So this isn't all of the farms. This is just like we're just starting to look at this data. This is like super preliminary. This is 1 year of data. So this is all like really early days stuff. But something that I saw when I was doing this that I just thought I'd share with you all is that the difference between the high and low yield for the control plots, it looks to be larger than the difference between the high and low yield on the biochar plots. And this is true even in the on the farm with more treatments, same thing. And so it leads me to wonder whether there's some sort of moderating effect on yield that the biochar is having. I also just can't help but wonder if this has something to do with the really dry year that we had and the impact of that lack of water. So that's something that we're going to definitely keep looking out for in the future. And we still have 2 more years of data to collect. So we're really excited to get our PFAS uptake results back and learn more about that. I'm super curious about yield in year 1 versus the following years. You know, is the biochar going to have more of an impact after it's been in the soil profile for over a year? We also have all of these other farms that we don't have data from yet, so our data set's just going to get a lot bigger. I'm also really curious about surface application versus when biochar is tilled in. So, you know, when it's just surface applied, I am really curious how far down into the soil profile we're going to see it at the end. Like, is it getting harvested off when it gets hayed? Are we going to see it move into the soil profile? I don't know. And, you know, kind of what's the difference in soil health outcome if it's surface applied versus tilled in? And also, is it worth applying an amendment that's this expensive for hay? That remains to be seen. I'm very curious about that. Or is it, you know, maybe it's more worth it for production of very high value, low land-based crops. And there's also one farm that is going to be adding biochar to their bedded pack. And we're going to be looking at the quality of the compost that comes out of the bedded pack with and without biochar added. That's it. This is how dirty I got when I was spreading biochar. So, you know, wear a mask.
Thank you, Sarah. That was fabulous. And we're going to have to do this biochar webinar again, because as Sarah said, that was first year results. And again, how yields do in year 2 could be quite different, but really interesting about the moderating effects. There's one question I do want that relates to you, Sarah. So let's deal with that quickly. Chuck is asking, how did you come up with the rates? And then I don't know if you can answer what farm is planning to add biochar to their bed pack. So let's get those 2 questions answered quickly, and then we'll move on to our 2 other speakers.
How did we come up with the application rates? Great question. In my opinion, the conversation about application rates for biochar leaves a lot to be desired. I see a lot of guidance that says you can apply between 1 and 10 tons of biochar per acre. And that's a huge range. And also the bulk density of biochar varies quite a bit depending on the particle size and the feedstock. And so a ton of biochar can be 4 yards or it can be 15 yards. And so it leaves a lot to be desired. We were calculating our application rate based on tons of carbon per hectare. So we were looking for, like, I think it was 3 tons of carbon per hectare added, or 6. So it was either 3 or 6 tons of carbon per hectare added. And that is based on research that was done by Debbie Aller at Cornell. And that's where we got that. Does it feel a little bit arbitrary? I will be honest. Yes, it does. But hopefully in the future, we'll be able to use these results to say something a little bit more meaningful about how much biochar needs to be added in order to see a meaningful difference.
Thank you, Sarah. That was fabulous. And we'll move on to our next 2 speakers. We have Hao Chen, UVM Extension Professor, who will be talking to us about some of her work on customized or engineered types of biochar. So over to you, Hao.
Yeah, so I'm going to share some more research we do about how to modify biochar or engineer biochar for nutrient retention, because that's a big topic for agriculture. Especially for Northeast, we have nutrient imbalance. We have too much phosphate and we don't have enough nitrogen because we have a lot of manure-based fertilizer. Can I go next slide? Yeah, so yeah, like Sam and like Sarah both talk about, we have different biochar. And what is biochar, right? It's basically like barbecue charcoal, and we just make it like a lower, like a different version of barbecue charcoal. And we definitely have different type of biochar. Both Sam and Sarah said they have different size and different content. And like we discussed the question about how much application rate of biochar, it really depends on what kind of biochar we have, right? If we have, like Sam said, those kind of like biochar, extremely like alkaline and have a lot of potassium, probably we can't apply that much. So I would say application rate definitely depend on what kind of like biochar we actually have and its property. And it's great to have Sarah talk about how to apply biochar because we always got that kind of like questions. And biochar works, right, for like carbon sequestration, that's for sure. And it's also help a lot with agriculture. And we are doing research, right? For like research, we want to expand why it works. So basically, it have a lot of like surface area there. And yeah, when we look at those like surface area, and it's not just for carbon, right? When we look at those like pause and the networking here, we kind of like think, hey, it can also add a lot of like functionality inside of those biochars. So that's our motivations to do biochar modifications to see like, hey, if biochar just for carbon sequestration, or it can do something else and make it dual functional or like a multifunctional. Like next slide, please. Yeah, so how we modify the biochar, we have different methods. So we work with like engineers, we have different methods to do that. Why we want to like look at different methods? Because different methods come with different like handling costs, right? We want something to be effective and easy to like handle that, not just to make those biochar, also for further applications. So we do have many methods to modify biochar. So we have physical methods, like we will talk about that with like bone milling. So we kind of like think that's easy way. And also chemical methods, probably you heard about that. They add acid or base to make it more functionality. And we can also add minerals. Some of the mineral we already know to hold a lot of nutrients. And for water treatment specifically, we can also add ions. And some research also add bacteria to inoculate that, to add like beneficial bacteria. They can mobilize phosphate, make phosphate more like a bioavailable, right? So these are different methods to modify biochar. They have a lot of beneficial effect. And in research area or like academia, it's kind of like well, like documented here. So, but we want to adapt that to more to the agriculture side. So that's our research, what we're doing. So I kind of like just give like a few examples about our progress. Yeah, would you please go to the next slide? Yeah, so those kind of like modified biochar, right? The motivation for us, like in UVM, for our group, so we want to like improve like soil quality and fertility. So like we said, biochar is not a fertilizer, but it can actually increase soil fertilities. So we're going to talk about this like later about evidence we collected. And also we want to like retain nutrients because for phosphate, we know the phosphate may go to the lake and cause like algae bloom. And also those kind of like nitrogen can go to the groundwater, cause groundwater pollutions. So we want to retain the nutrients in the root zone, right? So the plants can use that later. So that's the motivations for modified biochar and also reduce contaminants, mobility, and bioavailability. That is like Sarah talked about PFAS. And biochar do works very well with metals as well. And PFAS is the next big topic for us to like study with. And we definitely want to like see if biochar can support plant growth and promote microbials because we say like biochar provide the surface area and attract water. So like provide the perfect environment for microbials to promote their activity. We know microbial is a big like component for nutrient cycling. And next slide, please. Yeah, so this is one example. So we use aluminum oxide modified biochar for recover phosphate. So basically the motivation, right? We know a lot of phosphate go to the water. So we want to recover those phosphate from the water. And later on, we want to see those biochar like accumulate all the phosphate, can that use as a fertilizer later on? That's used biochar with phosphate accumulations. So the method we use, just use hickory wood, like chip is wood chips. Most about like wood chips depends on hardwood or softwood. The biochar quality is more or less the same. So we just add aluminum chloride to the wood surface and do pyrolysis. And after pyrolysis, aluminum transformed to aluminum cations to aluminum oxides. And they basically blend with biochar like carbon structure very well. So it's proved with our instrument with XRD and SEM, and we can see a big aluminum inside the biochar structure. Next slide, please. And what we did with those biochar, right? We make those biochar to have aluminum. What we did, we collect some water from wastewater treatment effluent, which have like a certain amount of phosphate. So it's kind of like removed like big portion, but still have phosphate in the effluent. So we use those biochar, do filtrations, and basically we have the wastewater effluent on the top and collect the phosphate in the biochar, and whatever leached out will be phosphate free. So those biochar, right, after it's reach the maximum capacity, we use that for like seed germinations, and we can see, right, the A is the biochar with phosphate, and B is just the biochar without any treatment, and the C is just the sand, the soil itself. And with the biochar, right, after the collect all the phosphate, it can act as a nutrients because the plant seedlings looks happier. It kind of grow bigger. So this is our the first study to collect the phosphate from the water and later on used as soil amendment. So next slide, please. So next, we also worked with another method. The first method, add aluminum, is one method to do biochar modification. And this is like ball milling. So basically, just put biochar and magnesium oxides together. And I think Vermont, we have magnesium, a lot of magnesiums. So we can put them together, just boil, mix them and use milling machines and just make them together for a few hours. And then those biochar and those magnesium oxides are mixed well. So next slide, please. And yeah, after that, we also did characterizations. Basically, magnesium oxides are distributed on the biochar carbon surface. And it also works very well to collect phosphate. We can see the phosphate absorption capacity increase a lot. And with biochar without those magnesium oxides, it basically doesn't hold any phosphate. But with those magnesium oxides, the capacity increased dramatically, right? With more loadings, I better capacity. So that's another way to modify biochar to achieve phosphate retentions. So next slide, please. Yeah. So current study in our group, we can think about, hey, can we retain not just the phosphate, but also nitrogen together? So we did a group for biochar modifications, right? We did find iron modified biochar and the magnesium modified biochar works most iron modified biochar. We have two different charges. They work both well with nitrate and phosphate. So it's kind of promising, right? We don't need to apply different biochar again and again. We just use one biochar with one modification, and then they can work well both for nitrogen and phosphate. So that's our current study. So next slide, please. So yeah, our next step, we want to say, right, hey, our biochar can retain both nitrogen and phosphate. So is that mean after we apply those biochar, we can cut the fertilizer like rate? So we don't need to apply what we used to apply, we just cut it to half. Is that still working? So that's our like next study. And we also want to see like if biochar can promote nutrient use efficiency to just hold the nutrients to the root zone, right? We don't want nutrients to go to groundwater. We don't want nutrients go to the surface water. We just want nutrients to stay in the root zone so plants can use it when it's needed. So yeah, so those kind of like key future research, and we want to see if biochar can really like function as nutrient buffering, right? As Sarah like showed, maybe make the yield more consistent and also promote like water quality. So that's our like next research like topic. So yeah, that's all for me to like present today. Yeah, thanks.
Thank you very much, Hao. I think that's really interesting about trying to keep the nutrients where they belong in the root zone, where the plant can use them, as opposed to having them leach out and affecting Lake Champlain. So really interesting. So we have our next speaker, Heather, who is somewhere on my screen. So Heather, if you have a chance to turn on your camera, and I think you have your slides ready to go. And Heather Darby is a professor with UVM Extension, runs the Northwest Crops and Fields group, and has done lots of research on biochar.
Working on it here, you guys.
Yep. Okay. Maybe while you're talking, this
Yeah,
is while you're getting sorted, maybe we can answer one of these questions.
Yeah, thank you.
This is a good one. Heather, who asked, what makes something a fertilizer? I'm having a hard time understanding biochar is not a fertilizer, but fertilizes soil. Does anyone want to take that on? Sarah, do you want to address that one? Because biochar as a soil amendment is mixed with manure. Does anyone want to take a stab at defining what makes something a fertilizer? So if biochar is not a fertilizer, how can we then say it fertilizes soil?
I would say biochar itself is not a fertilizer because most carbon, right? But some biochar, they're different. Like we work with tomato-made biochar, they actually like retain like nitrogen. If you have like a biochar just from wood, probably it wouldn't retain nitrogen. So all different biochars like different, and it works for soil fertility because it retains nutrients. After you apply the nutrients being grabbed, you can use it later. So that's how we expand that as a increased soil fertility. Probably not like a traditional defined fertilizer.
Yeah. So thank you, Hao. Yeah. So I think that the carbon nitrogen ratio of the particular biochar product use source will be important, depending on your uses. And it looks like Heather is ready to go.
Yes.
Thank you, Heather, for joining us. No problem.
Can you hear me okay?
Can we have a thumbs up from someone? I can, but I want to make sure everybody else can.
All right. Great. Well, thanks. It's been fascinating listening to everybody's presentations. And we've done a little bit of research on biochar through our program here at UVM. Some of that in collaboration with Carol Adair, who's at the Rubenstein School of Environment and Natural Resources. And in collaboration with one of her graduate students, Sophia Rubin, and Lindsay Rule, who is a research technician on my team. So the four of us have been involved in evaluating biochar, and our initial research was really focused on if we could reduce nitrous oxide emissions of liquid manure, dairy manure, applied to agricultural fields. And we were looking to answer that question as part of some of our work with Ben and Jerry's. And part of our work with Ben and Jerry's is focused on reducing carbon emissions coming from dairy farms. And so some similar objectives to Shelburne Farm. And we knew that Shelburne Farm was also applying biochar into their manure storages. But that's actually quite a difficult task to evaluate scientifically the impact in a manure pit. So we thought about the opportunity of directly field applying the biochar along with the manure to look at reductions. And a little bit of the reasoning behind that also was based on being able to control some of the items in the experiment, and then also being able to measure emissions, which is also hard to measure coming out of a manure pit. So that was the reason we started in the field. So again, we were looking to reduce emissions by adding biochar. There's evidence in the literature that indicates in laboratory studies and also in incubation studies that this is a possibility, but field studies are pretty limited. And that was what we really wanted to do, was look out in the field and see if this could work in the field. Right. So that's a picture of the biochar that we had. And to the right is a picture of it applied to the fields. So I'll just go on. Some of this stuff has already been talked about, but it's unclear in the literature also how biochar can actually reduce emissions from manure. And we did not look at the mechanism here, but there are some hypotheses around what's happening and why nitrous oxide emissions might be reduced. But again, our project was really to look at, well, if we apply rates of biochar and we apply manure, can we just reduce emissions? So the experiment itself was up in Alberg, Vermont, which is right on the Canadian border in the northwest part of Vermont. Many of you have probably been there before. Some of you may have seen this research. We had a number of treatments. We applied liquid manure broadcast, which is essentially just spinning it on the surface of the ground. And then we also injected the manure. We had a commercial urea fertilizer applied, and then we had a control plot that didn't have any manure or fertilizer. And all of these treatments were with and without biochar. So there was a total of 8 treatments and 4 replicates of each treatment. So again, manure broadcasted, manure injected, fertilizer and control with and without biochar. So I'm just going to get to some of the results here, which I think I'm showing you maybe what a lot of people want to see, including ourselves, was that biochar reduced nitrous oxide of manure. And it did, but it only did it once. In all the measurements that we took over time and years, we actually only saw one point in time, and this is it, that's what I'm showing you, where the biochar had a significant impact on nitrous oxide emissions. And it was quite significant. And this was in the first year of evaluation. And we were really excited about that. And we did repeat the study, and we didn't see the same difference in another year. So I think the positive aspect here is that it can happen, right? So this shows you that even in broadcast or injected manure applications, biochar does have the potential to reduce nitrous oxide emissions. Now, interestingly, if you look at the control, which had no fertilizer, and you look at the treatment where we were adding only urea, interestingly, what we saw was that when we added biochar, we saw more emissions. And there's, some possible potential explanations here. But again, at only one point in time. This was not a trend that we saw across the experiment. We, again, couldn't couldn't see this repeated in a second year. We also measured emissions in the same plots in a second year, and we didn't see anything. So we repeated the study in a completely different site, and then we also continued to measure emissions in the original site, and we didn't see a continuous effect of the biochar reducing emissions. So, I think again, the positive news is that we did see this. We didn't see it numerous times. We couldn't repeat it, but it did happen. And so, what was it about that point in time? Is this an environmental effect? Was it the right moisture and temperature to really capture a difference? But again, it was not repeatable, and we didn't continue to see this effect. And I do want to be clear about that what I'm showing you here is one point in time. But I think it's important, at least in my work, to know that it's possible. It's possible in the laboratory. It's possible under controlled conditions. But how do we make this a repeatable effect in the field? Is that possible? And that's really what we have to get a handle on. The other piece here is that the rates that we used were not agronomic. They weren't realistic rates. They were rates that we found in the literature that were used that showed nitrous oxide suppression with manure. So we used those same rates in the field. And again, they were exceptionally high. They were not economical at all. And when we saw these first results, what we were really thinking about in that moment was, wow, this could work. How low of a rate can we use and see this effect? Well, we didn't change the rate in the second year and we didn't see an effect. So again, there is so much to do here, research wise, to better understand how to replicate this effect. And again, similar to what Sam and folks are doing at Shelburne Farms, maybe simply putting the biochar in the manure pit gives us our best chance there. But again, it's difficult to study. The other thing we looked at was the impact on yields, corn yields. And this was corn silage. And so these are the 4 treatments with and without biochar. So the plus means that it had biochar, and then minus means that it did not. And we didn't see any statistically significant effects of the treatments with and without biochar. So biochar didn't hurt yield, but it also didn't improve yield in the 2 years that we did the study. That was consistent. We didn't see any positive effect or negative effect either way. Here is a table, a big table, but it tries to summarize some of the impacts we were seeing on soil. Okay, so this is physical, biological, and chemical characteristics that were measured in the top 6 inches of the soil. And this was the second year following application. Okay, so we applied the biochar in the spring of 2023. We did measure the same metrics in 2023, and we saw no effects. But we went back into those same plots in the spring of 2024 and measured the same soil properties. And you can see we did see some effects from biochar in that subsequent year. So as you would expect, when we had biochar, we had higher organic matter, higher soil organic carbon, higher total carbon, lower total nitrogen and higher soil protein. And then you can see some of the difference in nutrients. So these would be available nutrients that we saw some differences with. And overall, we did see an increase in the soil health score. This is with the Cornell soil health test when we were using biochar. And I think there was a lot of positive potential soil impacts from using the biochar, but that also was not translating directly into yield differences or quality differences in the crop. So not that this isn't for not on a farm to see these changes, but we have to be able to connect this back to economics and how, what kind of benefits the farmers will see in the longer term by using these types of products. In a dairy system in particular, which is what we were looking at, what are the benefits, challenges, and the economics. And so we have a lot more work to do. So I will stop with that. And these reports are available on my website. They're not held hostage anywhere. So you can go on and read all these details. I pulled this right out of that report. Wasn't even going to try to recreate this thing, but yeah. And Hao could answer probably a lot of the questions she already did for us on our team as to why certain things were higher or lower that we didn't understand from using biochar. So she's a great person to answer those questions. And that's it. That's all I have.
Thank you, Heather. That was great. And I should mention in the chat, Lindsay, who works with Heather, has put in the link for the reports that have been done on soil
Lindsay.
health. So
Yeah.
this is a really good segue because it's questionable about yields, but what's clear is that biochar increases soil health, increases soil organic carbon. And I think, Chad, it's over to you to talk about. Chad Cupit is an NRCS soil scientist, and we'll be talking about how NRCS in particular supports farmers to achieve some of these conservation benefits. So the jury's out on yield a bit. The results vary, but at least we know, which is really important, there's an increase in soil health, and retaining phosphorus is a good way to actually protect water quality as well. So thank you, Chad.
Hello, my name is Chad Cupit. I, as Suzy mentioned, the resource soil scientist for Vermont. And I am kind of a big advocate for biochar. So this is something that I did my research on. And I am going to give you a brief overview of what we have found here in Vermont. First thing I wanted to mention was that we have been doing a lot of soil screening at farmers markets across Vermont over the last few years. This is primarily for gardeners and for urban agriculturalists. And what we found is that there is a considerable amount of lead in soils, in addition to cadmium and chromium and some of the other things. So my first graph is the results of soil sampling over the 2025. And again, just to point out that there is quite a bit of lead, legacy lead from lead paint, in some cases, industrial, settings that have been turned into farmland. And biochar is one of the materials that have been found to kind of reduce the amount of plant availability for the plant. So it doesn't, of course, get rid of lead, but it reduces the mobility so that it can't be taken up by plants and end up in the food supply. The second thing that I wanted to talk about is that we just did some modeling on Vermont soils. So this is we just took all of the data from our Sergo data and plugged in a new model that kind of tell you about how much soil saturation or deficit you have based upon the mineral associated organic carbon levels. And you can see here in the middle that there are a significant number of map units here in Vermont. And these are mostly kind of constrained to agricultural soils, so not a whole lot of map units that are above 25% slopes, or map units that were very rocky or extremely bouldery, that kind of thing. So there's a lot of room to improve the amount of soil organic carbon that are in the majority of soils in Vermont. And lastly, is a graph that is some test data that Dr. Chen took from Shelburne Farms, where they had a control, and then there was land units that the biochar manure was applied to. And you would think, of course, that there was going to be more extractable phosphorus in the manure applied land, but it was not. So this is not a rigorous study, of course. This was just basically a snapshot in time. Dr. Chen took these samples last year, and this is just for the soil that is, it's the same map unit. It's in a similar landform or landscape position, and we find that there is substantially less mobile phosphorus. And these are the things that NRC of Vermont is trying to help farmers with, whether to mobilize contaminants, whether to improve soil health by increasing the amount of soil carbon, or to prevent phosphorus from escaping into Lake Champlain. So these are the payment rates for 336 for this year. So on average, we pay about $1,424.43 per acre. Now, to clarify, that biochar that we are paying that amount of money for must be IBI certified. It has to be greater than 80% carbon, and it has to be less than 10 parts per million of lead. There's also a minimum application rate, so you would have to apply a minimum of 4 cubic yards in order to receive that payment rate. But you can apply it to, and in the case of Shelburne Farms, if you wanted to duplicate the work that they've done there, you could apply this to your manure pond, your manure lagoon, your leachate pond, digestate, and then eventually apply it to the land. And as long as, again, you are meeting the 4 cubic yards per acre, then you can have the biochar kind of take that path to before land application. Just also, it was mentioned wood ash. So wood ash is a byproduct of power generation and is considered an other carbon amendment. And that is, of course, paid out at a lower rate. And you can, of course, also mix the two. You can, with a higher biochar rate and a smaller compost rate, or a higher compost rate, smaller biochar rate. And those are, of course, but these are the payment rates if you were interested in doing something like that. And lastly, so Environmental Quality Incentives Program, that's like our big program. That is where most people will find funding for this. We have a new program out. It's called the Regenerative Pilot Program, which you may have heard of. 25% of all the funding is going to go through that program this year, and it really only requires you to do soil testing in the beginning and the end of the program. And of course, we will pay for that. And now the Shrek Lab is set up to be able to do that testing. Conservation Stewardship Program is the same payment rate if you're interested in doing that through the CSP. And applications have closed for the year, but the application deadline is closed for the year, but we accept applications year round. So you could scan this QR code or go to your local office and put an application for next year. And here's my contact information if you would like to find out more about this. It's chadcupit@usda.gov.
Great. Thank you, Chad. And it's really good to know that NRCS is providing both technical and financial assistance for farmers applying biochar. So take note of Chad's email. And he referred to Shrek, which is the soil health lab. That's at UVM, where you can get the testing done. So good to see the emphasis on soil testing. We're going to share this recording, at least the first half, and take all of the questions and answers and come up with something that we can send back to you. So I'm really happy that, one, we had so many experts to be here with us today. And also, thanks for all the questions in this chat. If we did not answer them today, we will try and do that at a future meeting. And there's no question we will run another webinar, because what this has shown us is we do have the interest is there. Some questions we can answer, some we have yet to answer. So I really appreciate everyone hopping on with us again. And thank you again to all our speakers and panelists for sharing your expertise.